A warm welcome to today's webinar, which is jointly organized and created from 5G Alliance for Connected Industry and one6G. To give you a rough overview about our today's agenda, first of all, you get a warm welcome and a short introduction in our two organizations. So dear guests, dear 5G-ACIA members, and dear one6G members, we are happy that you are here, that you are listening, and also that you are happy to discuss with us later on. First, we will start with the industrial requirements and evolution from 5G to 6G. Therefore, we have Michael Barr. Then we follow up with Empower Waste Sorting Robotics with 6G. Al Costa will take this part. Then we will have an industry perspective, future industrial networks and automation, presented by Julie Ann, and followed this by future of robotics with connected intelligence by Yaman Erfanian. After that, there will be Q&A session. So therefore, we like to ask you to use the Q&A or question and answer item, which you see on the top line. So you can write down your questions, your contributions to the discussions. And at the end of all presentations, we will consider them and moderate the discussion among them. All of you are muted. So the whole discussion will happen via sending in your questions and contributions, and also use that to answer directly in between each other. So very shortly, who am I? My name is Michael Hertwig. I'm the head of the 5G-ACIA office. I'm, so to say, happy to contribute to our members' work on the strategic and tactical and operational level, that everything what our members want to do within the 5G Alliance for Connected Industry and Automation want to contribute to the community, that this is running smoothly and following some legal guidelines. To give you a very rough overview what the 5G-ACIA is doing, we have a very short, so to say, in a nutshell. So the idea is bring the connectivity to productivity, make 5G work for industry. Therefore, we have different formats. As you see on the left-hand side on the bottom, we have white papers, publications, we have events, we support pre-standard work, which means bringing together different perspectives and then helping them to be shaped for the standardization work, and of course, testing out the technology with test beds and providing guidance for potential users of the technology. As I said, we have certain events. You see on the left-hand side our upcoming events, which would be happening in September in Shanghai. We are also participating at the SPS fair in Nuremberg in November. The speciality of our alliance is that we bring together different perspectives, so to say. We have the ICT, so the companies providing the technology. We have academia doing the research on the technology. We have OT, so the companies who are taking the technology, providing this for the factory, and as well the end users who are at the end, hopefully benefiting from this technology. And bringing together these different perspectives helps us to shape 5G technology to be applied in industry. I think this is the most important information about 5G-ACIA. If you want to learn more, please feel free to reach out to our website or to the office or our members. As I said, please feel free to ask your questions in the Q&A windows, which you should see on the top line. We try to address them in the end, as many as possible. So please feel free to run that. And you will get further information on our website. The recorded version of this web seminar will be provided later, so probably in one week time or something. You can also share the link with your colleagues so that they may have a look inside if they weren't able to participate, or if you have to drop out earlier, you can also see the rest of the webinar later on. If you have any questions, any problem, please use the chat window or the Q&A window as well, or write an email to info@5G-ACIA.org. Now I want to hand over the word to Ricardo to give us a short glimpse on one6G.
Yes, thank you. Hello, I'm Riccardo Guerzoni from Docomo Eurolabs, and I am board member at 16G and liaison officer between 16G and 5G-ACIA. Just a couple of words about 16G. So 16G was created 5 years ago, and today it counts more than 160 members in 30 countries. And the purpose is to study 6G and experiment 6G and disseminate concepts and knowledge about 6G. The members are from academia, industry, and SME. And 16G delivers white papers that you can find in the website, and also publications related to 6G use cases and enabling technologies, and also experiments 6G technologies in test beds. And every year there's a 16G summit organized as in-person event, and this year it will be in September in London, hosted by KCL, and it's about connected intelligence for 6G. So this is a short introduction on 6G, but I invite you to visit the website to download white papers and see web seminars, and also come to 16G Summit in London. Thank you.
Thank you, Riccardo, for giving us this glimpse. Now I'd like to ask you to have a glimpse on our next speaker, on our first speaker. It will be Michael Barr. Michael Barr is a senior key expert and research scientist at the Siemens Technology Center in Garching. His works focus on future technologies such as industrial 5G and 6G, furthermore, private mobile networks and so on. He focuses on reliable low latency networking, especially for machine, robots, and autonomous transport systems. And of course, he's also involved in different standardization activities. So he is the chair of the Working Group 1 in the 5G Alliance for Connected Industry and Automation. And of course, he is also active in the 3G PPP standardization committees. Michael, the stage is yours.
Yes, of course, that's important.
Yes, how it works.
Yes. So thank you, Michael, again for your nice introduction and your hint. Welcome to our part 2, the first presentation on industrial requirements and the evolution from 5G and 6G. So for industrial use cases in 5G, we had these well-known 5G triangle with enhanced mobile broadband, ultra-reliable and low latency communication, massive machine type communication, and in 5G-ACIA, we looked at different use cases and placed them in different areas of the 5G triangle, since each use case actually looks for a certain set of, or pronounced set of capabilities. Some use cases need more broadband, some need more URLLC, some need more massive deployment. And of course, we are now moving into the 6G era. The development of 6G is starting and ongoing. And you still see the 5G triangle just in the core of the 6G circle, or whatever you would like to call it. And it's enhanced with new applications, new capabilities like ubiquitous connectivity, integrated AI, integrated sensing and communication, massive communication, immersive communication, and its URLLC is now called hyper-reliable and low latency communication. So enhancements, but also new capabilities, new applications, and actually also new goals or targets like sustainability, connecting the unconnected, security, privacy, resilience, and ubiquitous intelligence. So there's more to come, and let's see what are the use cases actually for industries and industrial 5G, and here I call it 5G 6G use cases, since the physical part of the cyber physical world did not change that much. There are new things coming up as well, but in the end you want to produce something which is physics. So you still have use cases which we call flexible modular assembly area, where you have assets like AGVs, AMRs that move around in the factory hall. So here the goal is to communicate with these mobile assets to support the mobility processes in the logistics and so on. Industrial automation is another important area of industrial use cases. That's really about producing something, controlling processes, controlling manufacturing. So here where you need the wireless communication between controllers and actuators, sensors, and this is really where you need the URLC, the low latency, the very high reliability, time synchronization. And the third group of use cases would be the Industry 4.0, which is sort of the ongoing vision of flexible manufacturing, where you might have flexible tasks, small tasks, the robots are moving around, cooperating. There might be robots carrying something, robots forming new working areas for producing certain things, task assignment, dynamically configured mechanisms, production processes, a lot of mobility, but still a lot of your LSC of high precision manufacturing. So everything together in a very flexible way and very dynamic. So of course, ITUR is looking into what is needed for IMT 2030, the official name of 6G, and they came up with this wheel of capabilities. The lower part, the green part, are the capabilities from IMT 2030, from IMT 2020, 5G. They are enhanced. And if you look closely in the center, there are the capabilities from 5G, and the outside are the assumed capabilities of 6G. The targets from 5G are still part of the 6G target. So it's not really being better for any price or at any cost. It's really, if you can do 5G, it's still okay. You would be applicable to 5G. That would be my interpretation for that. And of course, there are also some new capabilities which are added in 5G, but in 6G. So what is important for industry? Dependability is the important thing. It was important in 5G. It's still important in 6G. It needs to be, the 6G needs to be integrated into the non-3GPP industrial communication networks. That's very important in order to provide a good integration and cooperation between existing and future communication networks. The high communication service availability and reliability, that's very important. It simply has to work. And meeting the latency limits is important, especially for industrial automation. In the end, it's not so important to have the very low latency KPI. So the 1 millisecond might not be needed in any case. It's definitely not needed in any case. It's needed in some cases, but others not so much. But what is really needed is the high operational reliability, that it's working. It's better to work with a slightly higher latency than being unreliable with very low. And of course, stability, having hundreds of thousands of devices in the factory hall that can actually use these URLC communication, that would be very useful. And if we are in the middle between the Christmases, of course, the dependable, scalable 1 millisecond latency would be great in any case. But in the end, the use case must work. That's the goal from the OT companies, from the end users. We want to produce something. The way to 6G, 5G-ACIA looked into this and collected some consideration. One thing is that 6G should be an evolution in order to leverage the ongoing and upcoming investments in 5G technology, since the life cycle is actually much longer than in the IT domain, where you have a 10-year cycle for the generations in mobile communication. In the OT domain, the life cycles are 15 years, 20 years, or even longer. So it has to be an evolutionary migration or way to 6G in order to save your investments in 5G technology and enhance them with 6G capabilities. Let's have a look what would be important in 5G, but also especially in 6G. One important topic for the performance aspects, as mentioned already, is dependability and resilience. So the mobile equipment needs data acquisition, control scenarios, HEVs, industrial automation, multiple robots, synchronized control, mobile networks integrated into time-sensitive networks. And this is necessary to have also these features based on wireless networks, and that these provide more flexibility. So stable synchronization would be something, reliable latency. Here we write 1 millisecond of around 1 millisecond, as I mentioned. It might be actually a higher latency. And of course, the scalability in order to have many, many robots in a factory hall. Another thing which we call here operational aspects is actually simplicity and maintainability. So the mobile networks, the current mobile networks can be quite complex. So it would be necessary to reduce the complexity of the mobile networks adapted to the needs in a factory, for a private network, for a localized network, a simplified network management, and to have the functionality tailor-made to the industrial use case. So in factories, you probably don't need accounting of your users, since you are the only user of the network. Modularity and extensibility is one topic in order to allow new operating models, but also to tailor your functionality to have virtualization and softwareization. And an advanced exposure capability where functions, capabilities, parameters, and so on can be exchanged between modules in order to do diagnosis, monitoring, but also data exchange very easily in a standardized way. And another topic which is becoming more and more attention is actually sustainability. And the major aspect here is probably energy efficiency in factories, since of course we want to produce the things as energy efficient as possible, use only as much energy as is needed. This is especially important if you have massive asset management or massive deployments of network devices. So each saved energy multiplies a lot. Another thing is you could also consider the evolution from 5G to 6G as some sort of sustainability, at least from business aspects, but also from materials, since you don't have to throw away your still working network in order to have the next generation. But what is also very important for sustainability is the enablement effect of OT or operational technologies, since we produce things, and if these produced things can be more sustainable or can be produced more sustainably, that's also a second order effect towards sustainability overall. There are also a few features, functionalities, which have been developed in 5G already, that should transition into 6G, maybe with some enhancements. One is actually the non-public networks, which is important for factories, since they have a localized area, they have private networks, and so on. There's a lot of things, and there are still some things which can be enhanced. And of course, there are further things to be done in flexibility, deployment, simplification, and so on. Also, privacy and security is an important topic here. Another feature coming from 5G already to be transitioned into 6G, that's the seamless integration and native support of industrial communication domains in non-public networks or in mobile networks. So we have all these DSN support and DetNet support in 5G, which is already included in 5G and 5G Advanced. So this needs to be transitioned and still maintained in 6G, since the integration into the vast majority or vast deployments of industrial networks, mostly based on 802.1 technology, that's really important in order to introduce mobile networks in industrial factories. And here, of course, with new features, with new enhancements, this requires also enhancements for the good and seamless integration into the industrial communication infrastructure. But there are also new features in 6G, new capabilities, and these might trigger new use cases, new uses of mobile networks in industry and requirements. One important new feature is integrated sensing and communications, in short, ISAC. We have here produced a white paper, which you can see on the right-hand side, and you can find it on our website, together with other use cases, white papers on use cases like key use cases or use cases for machine vision. Or we looked into the state of the art in ISAC, but also looked into specific new use cases in the industry, for instance, gesture recognition, vibration monitoring, preventing hazards in industrial environments, but also monitoring of stockpiles and optimizing flexible production flows where ISAC can help in doing these things. Another topic which is also very prominently placed in 6G is native intelligence or artificial intelligence. Here there are definitely a lot of new applications, also AI applications running over the mobile network or the industrial network. So here the utilization of AI and decentralized intelligence would be the main application. But of course also the mobile network will use AI for controlling the internal processes and network management. There are many things. And also in industry, AI will play an important role in the production in, for instance, quality assurance and so on. Here you see the last sentence, 5G-ACIA will explore potential new use cases, functionalities and requirements on native intelligence. That has already been started, and we are looking in specialized groups already on the use of AI in industry over mobile networks. Another, it's actually an application. It's not a feature of the 6G network, but it's a very prominent application which is using the mobile networks a lot. That's real-time digital twins. Real-time digital twins are the digital representation of something physical, in this case a factory. And real-time means that it's sort of close to reality, and you can actually do many more things than just having a picture or a copy of your factory. You can actually use it for monitoring, you can use it also for control, you can use it for if then what, or if then analysis, for reconfiguration and so on. So it's becoming from just a simple picture or copy of your factory towards important and powerful means in controlling, monitoring your factory. Also use it as virtual environment for that. For this, it's really important to have real-time data within certain latencies, and it's a massive amount of data depending on what you want to monitor, you want to visualize in your digital twin. So here the wireless network, the mobile network, plays an important role in providing a reliable infrastructure for providing or transmitting all these necessary data in time and with the needed bandwidth. So let's come to some key messages on industrial requirements and the evolution from 5G to 6G. So the industrial 5G use cases and requirements, they are still applicable for 6G. These requirements are needed in order to produce something, and that's still the case in the 6G era as well. It's necessary to protect ongoing investments in 5G infrastructure, so that it's necessary to enable a smooth evolution from 5G to 6G. Of course, we would like to meet the future demands of the industrial manufacturing and so on. So the 6G architecture and services have to support this smooth evolution from 5G to 6G, and it should be really some thought in all these designs and developments in 6G to consider also the longevity and backward compatibility for as important requirements for the industry domain. And of course, industrial 6G is not the second priority things. Industrial 6G should be considered and should be considered from the very beginning of 6G. And as mentioned before, the 5G industrial features, as they are provided, the 5G are the benchmark for 6G and could be further enhanced in 6G, for instance, seamless integration. We have also discussed the new thoughts brought by 6G. We would like to see dependability and resilience, simplicity and maintainability and sustainability as major features. or guidance. And the new features like ISAC and AI exposure, agent technology, native intelligence, like discussed in the IMT 2030 vision from the ITUR, these will definitely trigger new use cases, new applications, and new requirements for industrial IoT, like supporting the network digital twin, the fuels, bandwidth, and real-time industrial metaverse, and so on. And in the end, the last key message, or the most important key message, is the use case must work.
Thank you, Michael. I think it was a very interesting insight. I think there are many questions. I'd like to remind you to go to the Q&A session and write down your questions. I already saw that some of our members and participants pasted already some questions, but let's answer and discuss them at the end. Let's come to the next speaker. Our next speaker would be Al Costa. Al Costa is CEO of Trash Robotics. It's a company who developed Alpha and humanoid robot who shall work in dangerous and critical environments. He is a serial entrepreneur, so he created and founded several companies worldwide. And he's also author of multiple books for technologies and teaches for big data and AI at the EAE University in Madrid. And with his background in biology and computer engineering, he brings together the right aspects to bring robotics forward and also understand how industrial communication is required. Al, the stage is yours. Either you share your slides by yourself, or we are going to share it. The stage is yours.
A little bit of our company, what we're trying to do. We provide robotic solutions to environments that are dangerous and sanitary places where people shouldn't be working, basically. And a prime example and our first use case is recycling plants. Recycling plants are notorious for being very unhealthy, very unsanitary. The most dangerous place you can work in the United Kingdom, even more than oil rigs, believe it or not, with the most deaths, and therefore a very challenging place for humans and ultimately a great place for robots to be working instead. However, we'll see that we have a lot of challenges in recycling, especially from the technical part, from the AI part, and this is where 6G comes into place. We are proud to be part of the one6G consortium, and we think that 6G is the way to go to solve the problems that we're facing. The problem with traditional humanoid robots is, especially in our case, is high power consumption. We have a humanoid called Alpha that works in recycling plants by picking up garbage, picking up waste from a conveyor belt. You have a conveyor belt, very fast, in which waste is passing in front of it, and you have operatives, workers, picking up paper, plastic, metal, whatever, and they do it for hours on end. And then, so it is something that requires speed and a lot of AI power. That ultimately means high power consumption. So even though Alpha is designed to, the battery can last up to 8 hours, our experience is that it barely lasts 40 because the conveyor belt goes quick and Alpha needs to pick up things, and it spends a lot of battery moving its arms and also identifying products. On identification, we have a lot of computational constraints because waste is very hard to identify. So when you take a picture when you identify usual products, would you just take a picture of that product in these many angles and end of story? However, with waste, the pictures are almost meaningless because waste comes in all forms and shapes, etc. So you need extra compute power to figure it out that this crushed thing is actually a piece of Coca-Cola bottle or whatever. That ultimately means that the computational cost is high, which means it is expensive. That makes the solution expensive, and then each alpha is 50,000 for initial deposit. Our model is RAS, robotics as a model, robotics as a service, which means that we charge a monthly fee equal to what the operative is charging. So if we replace or we add a robot, if we replace a human and this human earns 30,000, that's exactly what we will charge. However, we still have to charge 50,000 initial per robot, which I think is expensive. And very important as well, it is very dirty, so the robot all the time breaks because dirt gets into the pins, into the grippers, and then so therefore there's also the overhead of having to replace robots all the time. With that, very important, we created a cloud-centric approach, and this is where 6G is vital. The new system we are developing, actually, instead of the robot identifying products, which as we saw, it is very AI consuming and then power consuming, very prone to errors, we will do that over the cloud. So basically, we will use multispectral cameras on the conveyor belt at the beginning and at the end. So these multispectral cameras, as you know, they go beyond the visual range. So besides the typical RGB, red, green, blue, they also are able to look, to see infrared, ultraviolet, X-rays, you name it. And that's extra data that we can use to improve on recognition. However, that creates even more data for the robot to process, which of course makes it totally impossible for the robot to do. That's where the cloud comes in, because those cameras will send the data to the cloud, and there is a big computer with as many GPUs as needed, analyzing that data and sending back just what the robot needs to do. The robot doesn't even have to have a camera, basically. So the system should be able to identify that this piece of bottle will be in front of the robot at exactly this point, because the conveyor belt moves at a fixed, a constant speed. And therefore, all it has to do is just tell robot number one, pick up that bottle, robot number two, pick up that paper, etc. With that, we have a much better energy efficiency because, like I said, we don't have to keep moving the arms so much, trying to pick up things, missing things a lot, and then, which is wasted power. We can scale this much more because it's just enough just to increase the GPU power in the server in the cloud, and therefore we can add new robots. We much more flexible because the ML models improve centrally, so we don't need to upgrade ML models in robots. It's just one single ML model for everyone. And of course, we think that even though we will have costs on cloud, at the end, the initial 50,000 cost per robot will come down. However, there's a big connectivity gap, and this is where 6G is vital. The problem with recycling plants is that they are far away. There's smell. They are noisy. Nobody wants them around, which is understandable. So basically, we all the plants that we work with, they are always far away from any town, always with very little internet connectivity, and then so we cannot rely on them of having the best fiber connection. So we need to try something like 5G or again 6G, and this is where the beauty of 6G will come in, because we will need a lot of bandwidth, very little of no latency, because like I said, the conveyor belt waits for no one. It has to be reliable, and it has to have a lot of coverage. If we are, like I said, these plants are in the middle of nowhere. So with that, 6G offers us 5 things that we think it is vital. First, of course, the most obvious, ultra high bandwidth, peak rates of up to 1 tera, and then ultra low latency. We are hoping 0.1 to 1 milliseconds latency. High reliability, we're expecting error rates below 10 to the -6. Hopefully ubiquitous coverage, and also AI native networking. Basically, the system should be able to adapt itself to more demanding conditions. With that, these are the numbers that we think we would be working with. In 5G, we would hope for an 85% accuracy. With 6G, we think that we should be able to do 98%. With 5G, 5 to 20 milliseconds latency. With 6G, just 1 milliseconds latency. Uplink twice with 6G, going from 1 gig to 2 gigs. And I think that the most important is the 99.999. This is what we're aiming for. We want total network reliability. Of course, one thing is saying, the other is actually deploying. Easier said than done. So we need base stations, satellites, RIS, requires investment. We cannot do anything about that. I mean, if there are no 6G antennas near the recycling plant, all that stuff is meaningless. We need to see the energy efficiency, because terahertz frequencies and dense networks raise power draw. Of course, there's always security, because now we're doing cloud. So if this is someone gets into the system, it will be able to control all the robots in a plant. And then, of course, standardization. We cannot do anything about that, unfortunately, but we need a 6G that is standard, because we plan to deploy 1,000 robots all over Europe in the next 24 to 48 months, and then and 10,000 in the future, in the next 5 years. So if 6G is different in Germany than in France, well, that could create problems for us. The bottom line is that Alpha proves that uploading these sensors and computing to the cloud can make humanoids waste lighter, cheaper, and easier to scale. The missing piece is connectivity, and 6G, we think that is the answer. And then 5G, we tried, it just falls short. We don't have the necessary throughput to make a robot actually work the way we want. So that's my presentation. Hope you enjoyed it.
Thank you. Thank you very much, El. It was, I think, very inspiring. I saw that already a question raised. We will discuss that later. all the other participants, if something came into your mind you want to discuss, please write down in the Q&A session. Now I'd like to hand over to our next speaker. I'm happy to welcome Julianne, Dr. Julianne. She's working for Huawei Technologies Düsseldorf, and she's head of 6G Network Architecture Research Group, and as well active in the Heisenberg Research Center. Her research is focusing on AI native 6G network architectures, design, and how the business can be transformed by these new opportunities. Furthermore, she is vice chair of the Working Group 1 in the 5G-ACIA, and she's also vice chair of New World Europe, where she is also active. Furthermore, she is active in providing IP relevant information, so she is holding numerous patents and is also authoring in multiple peer-reviewed publications, especially in mobile communication and network domains. Her background is electrical engineering from the Delft University. Julianne, I'm looking forward to your presentation. The stage is yours.
Okay, thank you, Michael, for the introduction. And then let me just first launch my slides and put in the full screen mode. Okay. So thank you very much. Thank you, Michael's introduction. I think this is a very exciting webinar because on one side, 5G-ACIA has been working on the industrial 5G for many years. And on the other side, we know the new technology is around the corner. So I think this is really the perfect timing to discuss about like what we have been working on and then look forward what will be the next step. So from 5G side, as Michael introduced, I'm also working together with Michael Barr in the Working Group 1 as the vice chair. So over the past years, 5G-ACIA has engaged a lot to bridge the vertical side and the 5G side. So we are working on to bring the collaborations between the ICT and OT, and then we discuss the topics like use case requirement, and then we try to bring this kind of shop floor integration, IT integration in order to bring the 5G to the industrial field. And then we try to bring contributions to the standardization and then create this awareness. So basically what we are really working on is to become the bridge. This bridge will bring the industrial field together with the mobile communication field. So for this talk, I don't want to explain to you a specific technology because this will go actually a lot of time, and then you can already see actually 5G-ACIA already published a lot of white papers on the technical topics. But what I really want to do is to share the experience and also further thought, like why certain topic become important when we discuss about this industrial 5G, and then what would be the implications. So at the very beginning, when we say industrial network, and then we want to bring 5G to the industrial network, actually, the first topic, what we are trying to understand is what type of environment we are talking about, what type of network we are talking about, and how to deploy the 5G in this type of environment, and what are the use cases. So this is actually not as simple as we thought, because if you think about in nowadays consumer type of use cases, because everyone has a smartphone, we know how this business works in reality. And the base stations are deployed everywhere, and then they try to bring the coverage, and then smartphones are connected via the base stations. But when we come to industrial environment, actually the situation become much more complicated because as shown on this figure, you see the industrial network is not a simple coverage problem in a single domain because the industrial network itself by nature contains a different type of domains, like they have the IT domain, they have the OT domain. And in between the OT domains, they are talking about how to connect the controller level or from the controller to the device level. So basically, this actually the reason why there are so many different type of use cases from the industrial field need to be tackled, and then the requirements are actually very different. So as shown on this figure, this kind of a big orange arrow actually indicate what are the feasible links actually in nowadays use the wired connectivity, which could be possible replaced by the wireless in this context is 5G connections. So therefore, this actually create a kind of like a discussion scope, like what we are talking about and which type of device we want to connect it via 5G. And if that would be a reasonable way to connect. Yeah, because that is actually a lot of work we have been spending on this kind of use case and requirement investigation. Then another aspect, this is actually briefly tackled by Michael as well. So this concept of non-public network, I think this term also the first time come from 5G-ACIA. Like we spend a lot of time and also resources to bring the discussion and try to clarify what are the type of the network and how this could be done, what would be the different deployment scenario. So for example, as shown on this figure, so it could be fully isolated. It could have the different components to be shared. For example, you can share the run side, or you can share the run side or part of the control plane, or you can even have this kind of non-public network be launched via the public network, for example, using network slicing approach. So 5G-ACIA bring a lot of discussions and also consensus in order to let the industry understand when we come to the industrial field, actually the conventional public network cannot work well because the requirement is different, and also the user level is also different. So that is the reason we introduced the non-public network concept. But this could be implemented or realized actually with a different type of the technologies. And coming to the deployment, this could have different options based on the different scenarios from the region and also from a regulatory perspective. Okay. Then after we have the concept of this non-public network, another topic come into the core of the technical discussion is how should we integrate industrial domain with a 5G? Because as I mentioned at the very beginning, so it's not simply we deploy the 5G base station in the industrial environment, then things is done. So we need to think about the devices actually already running in this environment, which type of technology they are using, and then that type of specific type of traffic is coming from the industrial domain to the 5G domain, and how this could be considered altogether. So we work a lot of topic, like we work on the OPCOA and 5G integration. We work on the TSN and 5G integration, and so on. So I use the OPC and 5G integration as one example to just show you like how this is done in 5G-ACIA. So basically, we are talking about not a simple one technology to merge or to integrate with the other technology. Actually, we are talking about one ecosystem to work with the other ecosystem. So basically, what we are trying to rely on is this OPCOA, and then from technology-wise, is a kind of a platform independent standards, and which is used to connect the different type of industrial devices at different levels. So what we are looking at is this kind of a field level communication, because actually that requires more considerations on the integration perspective, and especially on the quality of service. So what I show you here on the right is one of the webinar we did with OPC Foundation. So what we show actually is one we bring to the discussion. Actually, we also want to bring this kind of a test bed approach to give the confidence to the partner to say this not only working on the paper level. Actually, it also work on the like a real testing device and so on. So on the left side, you can see actually there are different type of industrial controller from different companies. They are run on utilize OPCOA protocols to interconnect with each other. And then on top, you can see there are different two antennas actually to show actually this kind of a controller to controller type of communication can be done via the 5G link. So this is actually one of the approach we are trying to practice. Like we are working with not only a simple one type of technology, but we work also with the industrial ecosystem behind the technology, and then bring this kind of ecosystem level collaboration in order to bring the consensus. Then coming back to the 5G-ACIA, so what we do is actually we set up quite a lot of discussions with OPC Foundation and then try to align the requirement and also the technology thinking behind. So in the end, what we propose is on the right side at the architecture level, what would be the minimum requirement or effort in order to really integrate the two technologies together. So what we try to utilize is this kind of interface approach because we don't want to have this 5G to modify the OPC UA component or the other way around, but we want to align at this kind of interface level to understand how to really map the OPC UA traffic when it transmitted from one domain to the 5G system, and then how can we handle it in the right way. So this comes to the topic, for example, how to really map the quality of service from one domain to the other domain, and then which kind of interface you need. So even though this figure looks very simple, as I said, like we adopt this kind of interface approach, but actually the discussion was very lengthy. I think the whole project was running around 2 to 3 years, and then in the end we get a really clear understanding of each other, and then we try to publish this as a white paper. But then behind the scene, there are a lot of discussions and then a lot of terminology alignment in order to understand like what is the exact problem we try to resolve and how to really bring this from a theory level to really the protocol level and then really map to the different standardization group. Okay. Then another topic I want to highlight is this service level specification. So this is actually also related to the use case and the requirement, because when we come to the real deployment, actually especially for the OT side, they would like to understand how do you specify this service level requirement, because they are utilizing this kind of SLS not only for the modeling and definition, but they also want to utilize for the testing, like before you install all the 5G system, like you need to do the pre-testing. And then after you have the 5G system, you need to do the monitoring, and then you want to define a certain compliance and also violation rules. So this is actually very, very important for the vertical partner, but this is somehow kind of like a new type of practice for the ICT partners. So we also launched the relevant work within 5G-ACIA to bring the first thought on this SLS definition, and then this could be utilized for example, the service definition, testing, and then operation, and so on. So this is also a very important component when we bring the use case requirement to the real deployment. Okay. So far, what I share with you is the thought from 5G-ACIA. But what I want to bring this discussion also one step further, like what would be the observation, especially when we talk about 6G. So even though 6G will come around the year 2030, but the standardization work has begun their journey, and also it's a very important time to think about what we could do or what we could recommend for the 6G. So therefore, from this page on, this is not the consensus from 5G-ACIA because we are still working on our position on the 6G. But this is just bringing you some further thought from the individual members of 5G-ACIA. So basically, what we observe is like in 5G, you have a very different type of terminals, because when we come to the industrial environment, we are not talking about smartphone anymore. So we are talking about the machines. We are talking about AGVs, robot, or smart glasses. So this type of terminals actually bring a very different requirement in terms of use cases. So for example, I could say like I want to I need a video streaming, for example, from production line A with a 4K quality. So this is a kind of like a very specific requirement. Or we say I want to set up a temporary network to cover a customized production line, and which will only run from October 1st to 7th. So this kind of a requirement actually was worked out at the very beginning. For example, partners deliver their requirement to 3GPP-ACIA1. But we see actually based on our practice, this kind of requirement are very diverse. And then if you are working on the different sectors focused on different type of production, then the requirement could be also very different. Now, on the other side, we also see 3GPP actually defines a lot of functionalities and also procedures. So the combination of which could actually bring a certain customizations. And then on the other side, they also define this kind of capabilities, and then they want to expose this capability to the third-party partners in order to bring a new type of revenues for the 5G business. And then the same for the parameters, like you can combine different quality of service and then try to bring different, like a much more fine-grained performance compared to the previous generation. But then on the other side, we also observe gaps because on one side, 3GPP have a lot of capability, but that is not very easy for the vertical to understand. So this is, I think, we spent quite a long journey to align this kind of a terminology, to educate this kind of a capability, and then to see how the verticals could pick up this kind of capability, and then to try to fit to the use cases they have on hand. So that actually this is not a very easy way. And if you think about the vertical sectors, actually not only about the industrial automation, it could be go e-health, it could be go to V2X. Actually, then the complexity really grows. So this is actually one of the major gaps we observed. Like when you talk about mobile communication technology with verticals, and how do you really communicate with each other in a very easy way to say, this is a use case, and that I want to map my use case to your capabilities. Then on the other side, actually, the 6G journey already begin, and then actually involve already from the research to the standardization. So if you remember the slides shown by Michael at like a couple of years ago, so the vision of the 6G already set up to say like what do we want to reach as a final goal compared to the what we have in nowadays as 5G. But that vision actually set up much earlier than what the AI. The AI actually has a significant change of our society, because we all know in the past few years this foundation model actually really penetrate every single person's daily life. So I'm very sure all of us now begin to utilize this kind of like a foundation model as a kind of new way of search, new way of trying to find information. But then on the other side, we say actually beyond of this foundation model, we also have this agentic AI. So especially from 2024 to 2025, we say the agent actually become the major embodiment of this kind of a model usage. So model is you can utilize as a kind of a chat box. So you can ask questions, you can get answers, and this is still like a kind of like a way like it's kind of like a language model. But when agent come into the picture, so this is actually it try to reshape how we see our IT system, how we see our software development in a different way. And then we also know actually this AI trend is developing extremely fast. So every 2 months, 3 months, there's a new technology come up. And then if we think about the timeline of 6G is around 2030, and then what we will go through in the next 2-3 years, actually AI can really bring a very big difference about the technology in the future. So at this moment, one of the key questions, what we are trying to think about is how can we design a 6G which is AI native and also future-proof? I want to share you with one slide, but this is actually still a kind of ongoing discussion within 3GPP, especially in SA2. So nothing is confirmed because we are still in the study phase. But I just want to give you the flavor, like what is the current discussion, and then what is the view from the individual partner. So basically, what we see 6G is we want to bring an AI native design. So this AI native design is not only about we utilize AI as kind of an optimization model. What we want is we want to use this agentic way to reshape how the architecture is designed. So for example, what we see in future is the network architecture will go beyond of this network function based. You will have a different type of agent, and then the service definition, provisioning, and operation is based on this kind of a collaborative agent. Then in this way, the beauty is like then you can bring the flexibility and also the model capabilities to handle services in a much more diverse way. And then on the other side, when the user try to request of the service, you do not really focus only on the connectivity, because we say 6G is about the better connectivity, but also go beyond of connectivities. Then we will expect, for example, the user could bring their requirement in terms of, for example, this is so-called intent, and that intent will come to the 6G core network, and then the collaborative agent will handle the intent and then bring the service back to the user. So this is actually one of the discussion ongoing. And then we see actually in this way, this kind of new design will change. For example, you may need to introduce the new functions to the standardization. You may have the new interfaces because now if you talk about agent, then probably the communication interface will be how to enable the agent-to-agent communication or agent-to-tool communication. So this type of discussion will come up in the next few months. And then, of course, you need to consider what would be the new type of protocols. So one question you may ask, so why this is relevant to vertical? So what the 6G, AI native 6G could do or provide to the verticals? So one thing, what I have in mind is 6G shall address the challenges actually remained in the current discussion. So based on what I introduced you before, what we could see, for example, like three major challenges. For example, the long tail effect. Because when we come to the vertical side, what we observe is the players in the vertical ecosystem actually is very different from the mobile communication. Because when we come to the mobile communication, actually we are handling about the vendors and the telecom operator. And usually telecom operator is, the amount of telecom operator is limited. Like when we come to Germany, you may have 2 or 3. You go to Spain, still like you have a couple of them, like you can even count with a single hand. But if you come to the vertical side, actually what we learned is there are a couple of big enterprises, but then you also have a lot of SMEs. So this is actually is very different from the ecosystem what we have. And then we know the vertical side also have a lot of different use case. And how do you really satisfy this customized the use cases with the customized requirement? This could fit to a different scenarios. I think this is a kind of like a technical challenge we still need to resolve. And then on the other side, this kind of integration. So this is what I explained to you. Actually, you want to integrate 5G with industrial domain. It's not very straightforward. It's not like you deploy the base station, then everything works. So we need to handle this kind of a complexity. So you need to we need to handle like in case the industrial domain uses different type of protocols, different type of interface, and how do we really integrate smoothly. So basically, what we see actually all these challenges could be resolved by this kind of agentic approach. If you think about like the use cases, like this is also similar to what Michael explained. Like it indicate like a different. You come to the different scenario, the use case could be different. But if you think about a scenario, like if the AGV want to request a service, it just use a kind of intent. Like in this production line, there will be 50 AGVs, and they will move based on 10 meter per minute, and then they will have a whatever type of the data rate. And you put this as a kind of intent, and the intent could be handled by the network agent. The agent will provide the service to you. So what I want to say is actually this kind of a complexity about how to map the use cases to the requirement could be handled by the AI. So this could be really resolve big problems or challenges from the vertical integration. And then on the other side, when we talk about the native AI, then this kind of a runtime operations monitoring, closed loop control and optimization. So this is kind of like a added value coming with this native AI 6G network architecture. Okay. So for this talk, I only give you a brief idea and what we have been working on in the 5G-ACIA and what the observation would we take, and then what is the current interesting aspect in terms of 6G ongoing discussion. So basically, what we see is actually 5G-ACIA already worked on this topic since, for many years. So the first begin, this indicate like a 5G SARS around 2015, and 5G-ACIA was founded in 2018. And then actually we have a really high interest and also momentum around the 2019. So this is really the hottest topic back then. But over the time, we also come to the reality. We understand in order to bring this from the research to the standardization, from the standardization to the product, from product to the real deployment, this is a long path. So we are still working on that. And then we also quite confident. So even though the industrial 5G comes a little bit later than expected, but this is still coming. And on the other side, we want to bring our lessons learned or our experience to the public. And then we want to call for more partners to engage with 5G-ACIA. And also it's a very good timing to discuss about 6G. So even though 6G is still a topic will come maybe in a couple of years, but then the early standardization development already begin. So then from this side, we hope like we can bring the vertical topic continue from 5G to 6G, and then we also want to bring the new topic from 6G back to the 5G-ACIA. So this could be a very good practice for the next step. Okay, thank you very much.
Thank you, Shuli, for this very interesting insight and also the outlook what might come, and how also the Alliance is trying to cover that. Now I'd like to welcome our next speaker. It's Javan Erfanian. He's chair of the working group 6G architecture at one6G. Furthermore, he is senior director at the GTI Alliance. He has extensive working experience in wireless industry research and alliances. He, in addition, teaches at the University of Toronto, and of course, he is author of numerous publications. I want to highlight that he also is recipient of multiple highly recognizable awards. So, for example, from the IEEE. Ravan, the stage is yours. I'm looking forward to your presentation and the insights you are going to share with us.
Wonderful. Thank you. I hope you can hear me well.
Perfect.
Excellent. Allow me. You're good?
Yeah, perfect.
Excellent. Thank you very much. It's a pleasure to be among you and among the distinguished panelists. And thanks for great introduction and moderation. I think much has been said in terms of good insights from fellow panelists, and both in terms of industrial automation and real examples, as well as the technology evolution and standards. I will use this time to share some insights in this broader context that some of it has been covered, and connecting some of this also to the path we are in terms of connected intelligence, and particularly from 5G to 6G. But first, let me acknowledge there has been a great deal of related work in one6G and elsewhere, and we have also had work publications on ISAC, on robotics, and joint webinars, and also closely working with ITUR over the years, as was originally presented in terms of where it's heading. And also 3GPP, as was mentioned, both our members and also some of our presence in workshops. And the newsletter I have highlighted in here is important in some of the discussion we also have. But I move forward. What I will share in this short time we have is consistent, but pretty much my perspectives. So as a motivation, I quickly have shown this before in my presentations. I live in Canada, and we have a global ecosystem as a community, all of us, and aim for global standards. We also have specific and distinct requirements. For example, in a land like Canada with less than 4 people in a square kilometer, there is still not just limited to urban centers, but also communities and industries all over. And I'm only showing the mining industry in here. So as we move forward with everything we have said and all the targets and aims that 5G-ACIA stand for, in terms of return on investment, productivity, and safety, sustainability, and so on. This is what also brings a lot of these industrial automation and digitization. So, and we need all of the above in terms of a ubiquitous connectivity and as well as intelligent autonomous operations, safety, energy efficient solutions. And I would suggest that with all the innovative discussions and transformations we're talking about, it's also about design principles of how things may become more simplified, more flexible, although we embrace transformations into the next decade and innovations to solve some of the needs. Now, I have a couple of slides to make the connection. There are experts here in terms of industry, in terms of robotics, and so on. But allow me to make a connection here. First of all, when we look at some of these systems, you see that there are components which include a lot of sensors, connectivity, actuators, and also edge and cloud computing that was mentioned, AI and machine learning, in addition to the great works of brains and mechanics and locomotion and manipulation and safety engineering and so on. A lot of these, like sensing, connectivity, execution, edge and cloud computing, AI and machine learning, connect to this journey we are collectively working on in terms of the digital connected intelligence, and that's where the connection comes. There are the sensors, cover everything from position and motion sensors, proximity, vision, force and tactile, and environmental, and all of these are part of the topic. In fact, the ISAC paper, a great paper that 5G-ACIA published, also had tables from others, including a dozen from one6G. Now, one thing which is interesting in this picture that you see from World Economic Forum lately is that how, maybe even oversimplifying, but how we move from a pre-programmed rule-based environment, which will continue to exist, and it will have its speed and precision, perhaps for repetitive tasks. We have moved to a training-based reinforcement learning type learning of variable tasks in the middle. And this notion of training-based, creates a certain unpredictability that was not before. And this journey continues into this context-based robotics. And to put this simply, you can see, interestingly, how we go from predictable process in a known environment to unpredictable process in a known environment to an unpredictable process in an unknown environment. And this is where we are heading as a community, as a planet, in terms of all that man-machine communication, all that journey towards the artificial general intelligence that also Shuli and others talked about. So, however, I'd like to mention that these three will coexist in an automation strategy for their own integrity. Now, I think I like to spend a couple of minutes on this slide. What's important is this: when we simply look at the left-hand side, there's this AI journey, and all of these again are different aspects or manifestations. However, also growth and transformation. Generative AI and foundation models, as was said, is important and continue to be important. Even in, for example, the discussion on robots, we see that how they have become more intelligent, autonomous agents, and how they can have the ability to understand complex commands and engage in more natural context-aware interactions, increasingly with humans. And also respond to query-based needs. Now, agentic, as it was indicated, has this various level of autonomy, and it can encompass, with governance that we all talk about and still needs a lot of attention. But it's something that can do more in terms of updated material, in terms of retrieval, in terms of delegating multiple agents and so on. And those agents that was just shown becomes interesting. How do we go into a service awareness environment? How do we orchestrate these across different environments? And how do we bring multimodality, multi-party fusion of data into this? What I have as a title on this slide, Autonomous Cognition, Learning, and Collaboration, in many ways, I like to highlight this as a journey that we also see that, simply in the box you have on the left-hand side, you see we have sensing and perception, and we have reasoning and comprehension, and then decision-making and execution. Right, and this is growing, and the systems that become more and more autonomous can do end-to-end. Again, it's still discussed in terms of oversight and in terms of human in the loop, on the loop, before the loop, after the loop, but nonetheless, it's about how we interact and sense and reason. And there's a lot of paradigms in here in terms of, for example, the ability to comprehend, but that doesn't necessarily mean for a machine ability to do things. There's this paradox, as you may know, that is talking about all this intelligence that can probably beat the champion in chess, but not be able to do some of the simple tasks that a one-year-old can do. And that's the path that we are talking about in terms of being able to do things increasingly effortlessly and in collaboration, not in substitution. So the reason I said the title of this is important, you also see on the top right-hand side the work that ITU is doing on what's called embodied AI. Now, to put some of these terminologies in perspective, there's a lot of discussion about physical AI, about embodied intelligence, about embodied AI. It's about how we interact with the physical environment and collecting data, manipulating, updating, and so on. But it doesn't necessarily mean that these are one and the same. With a robot, there's a lot more, for example, to a robot. And then there are other machines as well. So it has to be put in perspective. In fact, when it comes to intelligence, it's interesting because a lot of times there are recent innovations for robotics, and I apologize, I may not be an expert in robotics, but that are working on the brain, which is agnostic to different kinds. And it becomes almost like a general purpose. And it is incredibly amazing how they can, and the data, the experts may agree, the data in physical environment is not as easy the collection of reliable data as it is when we do algorithms and computation and software and so on. It can still be synthetic in terms of using physics and so on, as well as also using, all the literature that's out there, like all the videos on the internet. Nonetheless, that notion of physicality, which robot is a prime example, but it applies to other things as well, is well shown on the picture on the top right-hand side. So there's a physical world and there's a physical body. The foundation model is always the thing that provides the context and information, and of course this relationship makes this agentic, makes this physical in the sense of continued interaction with the physical world. Those three words that you see in the middle of the picture in the arrows on the top right-hand side, cognition, learning, collaboration, is the journey. And cognition can include, even in ITU terms, can include the process of perception and decision making. And then there is learning and collaboration, collaboration between human and machine, which is the target of many discussions among machines. And also in a broad sense, this notion of distributed intelligence that we talk about, also Al talked about using cloud, and how moving from 5G to 6G, we have a greater flexibility in the sense of in-network computing, making things more embedded, more native, for the idea of making them more flexible and simple. And as we do that, the notion of intent, the notion of being able to orchestrate agents is supposed to create, for example, distributed intelligence, such that we can dynamically go between the loads, between the device, edge, and the cloud. So I won't spend much more time on this, but this is extremely important, and that there's an increasing focus on this physical AI, as you know, the embodied intelligence, embodied AI, and research, as is shown in the picture on the bottom right-hand side, in terms of what it entails, because at the end, when you're leaving most of the job, depending on the level of autonomy, to an autonomous system, then you have a loop of this, perception, reasoning, decision-making, execution, and then we have a responsibility to decide how we design that and how we govern that. I move forward. In our journey, and I don't want to indicate where the mobile journey is, I'm more than saying that this notion of man-machine communication has impacted a lot of the things we have been doing, from virtualization, cloudification, to Internet of Things, and increasingly coming to this industrial IoT and other things. A lot of these, even though Shannon lived to see a lot of these things, but the point at the time was not, for example, a semantics or a knowledge base that is desired by a machine. So that is also brings a lot of interesting things in here. How do we combine, integrate sensing and control and computing and communication? How do we create a knowledge-based, semantic, intent-based, so that the machine may not need the entire landscape. It may just need to see the sign. It may just need to see the obstacle. So this is important. And at the bottom, I've indicated these are not without design and overarching requirements, technical or non-technical. We can talk about 6G transformation. We can embrace innovations. At the same time, we can understand and agree on design principles in terms of protection of investments, in terms of 5G interoperability, in terms of integrity of 5G use cases, which continue to evolve, and how we can make better use of how we can enable these in a better way, in a more flexible way, not in a rigid way. So that picture that at
Javan,
the beginning, yes.
Maybe shortly come to an end, maybe in 1 or 2 minutes, because we want then also answer the questions which have been raised.
Okay, so actually, I can bring this together. You know, these are all the different aspects that at the beginning was shown in terms of ITU and IMT2. But this is interesting that we need all of this ubiquitous connectivity. That low latency was mentioned. In fact, it is for specific needs, and that was a user plane for some indoor industrial. But we need all of these journey with integrated sensing to be able to create that flexibility, that distributed intelligence, that integrated sensing, and so on. Now, this is a perspective. What is important is how we move to an inclusive, responsible transformation, how we create those orchestration of agents, how we make it intent-based. And in many ways, when we have data and intelligence which is ubiquitous and across layers, then governance becomes part of the infrastructure. So in many ways, we are harnessing new frontiers, and some of these slides will provide some insights. If anywhere from quantum to 3D connectivity to RIS and tunable radio, and how we do new things in smart life, smart cities, including waste management that was given as an example, resources, and how do we do beamforming as a service so that we can go where it is needed, for example, certain industries and so on. So it's both temporal and spatial, and many more examples in terms of how robotics. I think it's important to understand that in some of these contexts, how they become more collaborative, modular, reconfigurable, how we can have swarm of them with trajectory planning and so on, how we can have soft ones, which also brings us to physical AI, that the morphology can become part of the knowledge base. So this is the journey in terms of how they become more intelligent, more reconfigurable, and more cooperative and collaborative. And allow me just to say, allow me just to say that with that example I showed at the beginning on mining, a lot of these have already started to provide input. The industry has become more automated. There's a lot for hauling, for remote operation, for automatic mobility and even robots for analysis of core samples. Teleoperation becomes important. Connectivity becomes part of that. And of course, it's all about simplified, modular, and efficient activities. So I tried to wrap up the last few slides because of the time. There was also a slide from GTI that it takes a lot of things to bring all of this together as a global ecosystem and global standards. And there's a convergence of many fields involved in this. And of course, we'll be happy to answer questions as well. We also saved the date for our summit on September 10 and 11. And I stop here as you advised. Thank you.
Thank you very much, Javan. It was really, really impressive what you are willing to talk about. Thank you very much. Now we have the possibility to answer the questions. So we received some. I tried to cover almost all of them, if possible, concerning the time. We have now roughly 15 minutes to discuss these questions. Maybe I raise the first question towards Michael Barr. There was a question, can private 5G UEs used in private 6G networks? This should be important to be considered in installed base to be future-proof, I think. What are your opinions on that?
Yes, it's definitely the right question, and the answer is that it's really, well, and the question is really important, and that, as mentioned by Ewald, is actually one of the things you would consider if you run a 5G network for saving your investment. And 3GPP takes that time in order to do certain decisions, especially which have deep, very deep consequences, like the architectural design of 6G. There are good indications that the 6G architecture will be able to support this, that 5G devices will be used in the 6G network. There's something like the multi-red spectrum sharing, which would support this. Also, other general concepts on the 6G core network, where the general idea is to have an enhanced 5G core network, which also with enhancements for 6G, but still being able to 5G. So I'm quite confident that this will be the case in the future, that 5G devices can be used in 6G networks.
Thank you, Michael, for this clarification. Then there have been two questions towards Al and concerning his waste robot. So there was one question whether the waste sorting use case not can be used or not can be operated by edge compute. So on premises, why to use cloud computing? Because taking the data from the cloud will maybe also increase the overall cost and the solution for data transmission and latency. Whether this is whether there is a possibility to clarify that. And then there is another question which, from my perspective, goes in a very similar way. How important is synchronization for the waste robot? Is there a need to have a synchronization from the robots towards mobile network and into the cloud application?
Well, regarding the first question, I think that during the presentation I mentioned that yes, there could be an increase in costs due to cloud, and anyone who's ever used cloud knows that is a black box. I mean, of course, the cloud provider will always tell you that it's going to be inexpensive, but you finally get a bill that is totally the opposite. However, we're trying to lower down the initial cost of 50,000, and then which covers up to 12 months of training. There's something that I need to explain here. The training process takes up to 12 months. Of course, we want it to be as short as possible because we want to start charging the monthly fee. I mean, that's the entire business model. We don't sell robots. Remember, our model is RAS, robotics as a service. So we charge a monthly fee, just like a regular employee, I guess. But however, it requires a lot of training, a lot of fine tuning, we need to keep messing around with hyperparameters because we want to extract every single byte of performance from the robot because it's already on the very top on usage, and therefore each byte that we are able to get, it's advantageous. So that I would say that only 30% of the price is actually the robot. The 70% more or less is the training process, which is due to the limitations of the robot. So that creates a big barrier for new customers because they think, okay, 50,000 per robot, that's a lot of money. So we think that by reducing that initial cost, then we would create more business opportunities. And so cloud would be the answer because you would transfer all the computing power, all the training period, etc. So instead of being up to 12 months, it would be 1 month of training. And then, so at the end, we think that it would be much cheaper. And the second question, what was again? I'm sorry.
No problem. How important is synchronization of the waste robot? So is there a need to synchronize the robot towards the mobile network and then also towards the cloud application?
Oh, yeah, that's actually a good question. The idea is to sync is a major thing in this new vision that we explained, because we don't want the robot to identify products, remember. So in this new system, the camera, the hyperspectral camera at the beginning of the conveyor belt will identify products, and it will just tell each robot to just go and pick something that is located at a specific part. And then the robot hand will just move to that particular area and pick whatever. Because if we have to also ask the robot to identify this chunk of metal or whatever that was seen by the hyperspectral camera, well, we go back to the initial problem of being hard to identify, et cetera, et cetera. Synchronization is vital, pivotal here. So once the camera identifies a chunk of metal, it will need to synchronize when it will be exactly in front of the robot, the robot's arms, and just send a mapping to the robot saying pick up whatever at this specific point. I hope that I answered the question.
Thank you. Maybe the question will be added if it's not clarified yet enough.
Yeah.
Maybe another question towards Julie, to her, so to say, foresight, what might be coming with 6G. Are there, or the question is, interoperability tests are in operation and a must. So like Profinet, does this other plans for 5G cores and also for 6G cores and devices to have something similar, and what need to be considered concerning the migration and the pathway towards 6G?
Yeah, I think this is a very good question. So maybe the first bigger question is like, what is the format of 5G, and then the already existing investment happening in the industrial 5G environment. I think this is an ongoing discussion because when we talk about a new technology, one of the first questions coming from the service provider is how to handle or how to move from one generation to the next one. So definitely, I don't have a good answer at this moment because it's working in progress. But I can, what I can confirm you is migration is definitely one of the key topics to be discussed, and then especially how to handle this under industrial domain. So I think what you mentioned is fully correct. So many topics like what I mentioned in the talk, OPCOA over 5G, TSL over 5G, and also Profinet over 5G. I think these are the ongoing topic happens already in nowadays. And then from 5G-ACIA perspective, we will further bring this discussion to the 6G because I think for the OT partners, one of the important things is what they invest today should be protected for the tomorrow. So we are very positive about that.
Thank you, Julie, for clarifying that. Yavan, you talked about agnostics and agnostic AI. So maybe another question is, do you see that by using mobile communication in future, using 6G or even 5G advanced, independently of what physical object we are talking about, that these kind of objects can be in future controlled by using similar ways of providing skills and then simplify the whole control? Is this something what you see coming up?
Thank you for the question. So are you indicating whether there will be a physical interaction to also learn, or?
You presented this physical AI, and
Yes.
the question is now, by evolving the communication, whether this reduces the effort in controlling different devices by simplifying the control across various machines or assets.
Well, the whole idea is when we do use multi-agent orchestration and an agentic system, the whole idea of having an intent-based dynamic resource allocation is to make it simple. Of course, in that, depends on the use case and interaction, and this is also a new concept, and I don't speak on behalf of standards. As Shuli said, it's a study item and there are variants in terms of how to do this, but the principles have been how to create more simplicity. Now, it is true that it makes it simple by virtue of, for example, integrating sensing and perception, by integrating embedded intelligence that can make decisions and towards execution, and by creating an environment which is probably evolution of slicing in the sense of simplified goal-oriented resource allocation in those sense. But of course, there is a lot of things in terms of that physical AI that 5G to 6G can do in terms of distributed intelligence and security, resource allocation and connectivity. That's the expectation. So I would say yes, and we are hopeful, and more work is to be done.
Thank you very much. And now I want to send a question to all four of you. Maybe you have some different views you want to share. So in the beginning, Michael showed the wheel of capabilities, which shall be reached by introducing 6G communication. If we are talking, or as we are talking currently about 5G and 5G advanced, which is currently the way how the industry may use this technology, and 6G is still further away, what of the required advancements you see at the moment already there, and what is the giant leap which need to be done to not only bring in the new technology on a, so to say, technical level, but also support the industry also in future, as we currently strongly push the application in the industry? Who wants to start first?
I can start maybe.
Please, Michael.
The first presentation. One thing, of course, is that you have different stages. Yeah? Of course, there's research, which is 6G a lot. There is standardization, which is currently starting in 3GPP. So 6G is becoming a reality, at least in the specifications. And then, of course, there is the implementation of the standards, or what is standardized. And that's still awaiting for 6G without any specific specification. But of course, people have some ideas, and there are already first implementations of prospective things. The same is also true for 5G, of course. We had research, we had specification, we had implementation in chips. But as we know, for industrial 5G, it's slower than expected. But Julie mentioned that it will be coming. So one of the operational aspects is not so much on 6G, but it's rather on promoting 5G, getting 5G really used in the field, in the factories, and yeah, getting a successful ecosystem on industrial 5G, which will then lead into industrial 6G. For that, it's also very important to have an evolution of 5G to 6G, since even if we are talking about 6G and there's a lot of happening in 6G, we are still at a rather early stage in the deployment of industrial 5G. And Ewald mentioned in his question about the interoperability tests for 5G. Yes, 5G-ACIA is working on that. There is some work which is quite far advanced already on the requirements for certification and test, but of course it's nothing you can do in 1 week. It's something which needs the time, the experience, and also the learnings from the first installations of 5G, but it will come, and 5G-ACIA is actively supporting this path.
Thank you. Are there any further aspects?
What we like is, I'm sorry. Well, I was going to say what I like of 6G is I think that would be most advantageous for us is the slicing. I mean, by creating sub networks, if I may, I think that at least in theory, you would provide us with a set of rules and technologies, etc., almost like having a private network for our specific needs. I think that is unique. So it's almost like we have our own private network. That's how I see it. And if it becomes true, I think that will mean a lot. That's my vision.
Thank you.
Yeah, Michael, if I may add something, because I think one thing we learned is the OT vertical side has a very different life cycle compared to the ICT. I think this is also something we try to advise to the corresponding standardization body to be aware of that. But at the same time, as addressing in my talk and also Javan's talk, AI is coming, and the evolution speed actually even faster. And then I'm really sure AI is not only penetrate the telecommunication field, but the vertical field as well. So I think we need to anticipate this kind of new technology and its impact. So therefore, I think definitely this will open some topic we never touched in 5G-ACIA before. So definitely more interesting work will come in the next few months and years. Thank you.
Do I have time to add to say
just a minute, yeah, please.
Yes, actually, I probably echo what was already said, but this is important because first of all, I think there must be a balance between demanding design principles, requirements, and also smooth migration to also embracing possibilities as we go to the next decade. There's a lot that can be happening in terms of connected intelligence, including, for example, what was said as a slicing, but it's a really, if you can do dynamic resource allocation and networking and what you need to do based on what the need is itself, and there's already a lot of work even in standards at all levels to shrink the feedback, to shrink the pilots, to shrink the protocols, to do scheduling and so on. That goes a long way. So I think we should embrace innovations and at the same time ask for our requirements. Thank you.
Thank you. Thank you very much for this great discussion and the great questions also from the audience and to discuss these. Now, maybe just to highlight, because we had already the remark from 16G about their summit in September, there will be 3 upcoming events also from the 5G-ACIA. You see here the Industrial 5G in Shanghai. We will be on the SPS fair in Nuremberg, and as well the 5G demo day will be happening in Aachen in December. If you want to know more, then you can also follow us on LinkedIn or visit our website. Please feel free to follow us, to visit our website, or even to reach out either to the office or to the members you met already today, or even to one of our members. I'd like to thank you very much for your presence, for your interest, and I'd like to wish you a nice afternoon and evening. thank you very much for being part of this web seminar. Thank you very much and see you soon. Bye-bye.
Thank you for inviting me.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Great job. Thank you.